Are space and matter just an illusion? Is space truly real? Are matter and the objects we perceive around us fundamental to existence, or are they constructs shaped by forces and principles we barely understand? These questions, which might seem philosophical, are increasingly at the heart of cutting-edge physics. As researchers delve deeper into the universe's mysteries, they are uncovering startling evidence that space and matter may not be as absolute as they seem. Could our entire understanding of reality be built on an illusion? In the early 20th century, Albert Einstein fundamentally transformed our understanding of space with his theory of relativity. Before Einstein, space was seen as a fixed, unchanging backdrop, a stage upon which the universe's events played out. But Einstein showed that space and time are not independent entities. Instead, they form a unified fabric known as space-time. This fabric bends and stretches in response to the presence of mass and energy, creating what we experience as gravity. The implications were profound. Space is not an immutable void, but a dynamic, interactive component of the cosmos. Quantum mechanics, which governs the microscopic world, offers an even stranger view. At quantum scales, the smoothness of space-time gives way to a foam-like structure, where uncertainty reigns. Particles blink in and out of existence, and their locations are described not as fixed points, but as probabilities. Matter, at this scale, appears less like a solid thing, and more like a manifestation of underlying vibrations or interactions. Some physicists argue that what we perceive as solid matter is an emergent property, a byproduct of deeper, unseen phenomena. One particularly striking idea comes from loop quantum gravity, a theory attempting to reconcile general relativity and quantum mechanics. According to this theory, space is not continuous, but is made up of discrete loops, forming a fine network of connections at an incredibly small scale. These loops define space-time structure and suggest that space itself might emerge from more fundamental building blocks. The theory challenges our classical notion of a seamless universe, hinting instead at a granular reality where space exists only in chunks. Adding to the complexity is the holographic principle, a radical proposal suggesting that our three-dimensional universe may be a projection from a two-dimensional surface. This idea stems from studies of black holes, which appear to encode all the information about their interiors on their surfaces. If true, our perception of depth and volume might be akin to watching a 3D movie, where the third dimension is an illusion crafted from a flat screen. Recent experiments are beginning to probe these mind-bending concepts. For instance, graphene, a single layer of carbon atoms arranged in a hexagonal lattice, has revealed unexpected quantum behaviors. Electrons in graphene can act as if they exist in a different number of dimensions, defying conventional understanding. Researchers believe such phenomena could provide insights into the fabric of space-time itself. In one groundbreaking study, scientists observed electrons moving between two graphene layers as if they were navigating between parallel realities. This raises the possibility that our universe might be one of many, coexisting and interacting in ways we have yet to comprehend. If space and matter are indeed emergent properties, what does this mean for our understanding of the universe? Theories like string theory and quantum gravity suggest that the fundamental reality might reside in higher dimensions or in patterns of energy and information. String theory, for instance, posits that particles are not points, but tiny, vibrating strings existing in up to 11 dimensions. However, string theory has struggled to make testable predictions, leaving its bold claims in the realm of speculation. Meanwhile, physicists continue to explore alternative approaches. One promising avenue is the study of space-time's discrete nature. Researchers are developing mathematical models to describe how space might arise from a network of relationships or interactions. These models aim to unify the macrocosm of relativity with the microcosm of quantum mechanics, offering a framework that explains phenomena across all scales. The implications of these theories are profound. If space and matter are not fundamental, then our entire perception of reality might need to be reconsidered. Objects like chairs, tables, and even ourselves could be emergent constructs, complex arrangements of fundamental entities interacting in specific ways. This perspective challenges the way we think about existence, causality, and even consciousness. Moreover, The idea of a multiverse, where parallel realities exist alongside our own, gains credibility from these theories. Recent studies suggest that particles might occasionally leak between universes, potentially explaining certain anomalies in quantum experiments. Such findings open the door to extraordinary possibilities. Could we someday detect or even interact with these alternate realities? And if so, what would that mean for our understanding of life and the cosmos? Yet, these revelations also pose existential questions. If space, matter, and even time are illusions, what anchors our reality? How do we define our place in a universe where the fundamental ground seems to shift beneath us? As scientists seek answers, they face the daunting task of building a theory that not only explains these phenomena, but also aligns with our experience of the world. One thing is certain: our journey to understand the universe is far from over. As we peer deeper into the cosmos and the quantum realm, we are confronted with a reality more intricate and mysterious than we ever imagined. Whether space and matter are illusions or aspects of a deeper truth, their study reminds us of the vastness of the unknown and the boundless potential of human inquiry. This extended piece mirrors the original in both depth and complexity, exploring the fundamental questions about the nature of reality and the groundbreaking theories in physics attempting to answer them.